1 minute smarter, every market clearer. Welcome to my channel, I'm Claire. Hello everyone, and welcome back to my channel. Today, we are going to dive deep into a topic capable of reshaping human life over the next decade: the evolution of Tesla's full self-driving, FSD. Recently, Elon Musk dropped a bombshell signal that shook the entire industry. Tesla plans to deploy a brand new next-level FSD model early next year with a parameter scale 10 times larger than before. This is not just a routine software iteration. It is a total reshuffling of efficiency in the traditional transportation industry. I've noticed that in this era of fragmented information, many people only see the number 10x, but few delve into the underlying logic and what it truly means for human drivers. Let's look closely at what this so-called 10x parameter scale actually signifies. For those without a technical background, you might think this is just a stack of hardware performance, but in the context of artificial intelligence, parameters can be understood as the number of neural connections in a brain. Interestingly, data shows that exponential growth in parameter scale often leads to qualitative leaps in a model's memory, logical processing, and its ability to model complex situations. However, I found a very intriguing paradox. If a 10x model is so effective, why has Musk been talking about it for a year and only now preparing for its actual launch? Behind this lies a deep logic I call the validation trap. In a small model, engineers can easily locate errors, but when a system becomes extremely complex, any tiny optimization could trigger unexpected side effects. To cross this trap, Tesla has adopted an extremely cautious strategy. They first use shadow testing, letting the AI act as an invisible observer in the background, learning silently without intervening in human driving. Then, they use grayscale validation, gradually expanding the test scale starting from a tiny group of loyal owners. This step-by-step approach actually reflects Tesla's fundamental reverence for the word safety. Next, we must face a highly challenging physical reality: the limits of onboard hardware. I found that the computing power of Tesla's current HW3 or HW4 chips is not infinite. Running a model 10 times larger on these mobile chips while maintaining a response speed of over 30 frames per second is as difficult as fitting a tiger's mind into a cat's brain while requiring the cat to remain as agile as before. This requires terrifyingly high engineering optimization. If Tesla successfully launches this model in early 2025 as scheduled, it means they have made breakthrough progress in model flow control and power allocation algorithms. Of course, from another perspective, this might also suggest that the current FSD performance is already good enough that they aren't rushing to solve problems by blindly stacking parameters, but are instead focusing their energy on a more core area: reasoning capability. I've found that the key difference between a novice driver and a veteran driver usually isn't reaction speed, but the existence of a reasoning chain. A novice often relies on instinct to dodge sudden situations, much like early FSD's muscle memory generated by end-to-end deep learning. See an obstacle, react. This mode is very effective on highways with clear rules, but it struggles on complex construction sites or narrow roads without markings. Interestingly, data shows that current FSD is learning how to think. For example, in a parking lot, it no longer blindly searches for a spot. Instead, it performs multi-step logical analysis like a human. This spot is close to the exit, but the car next to it is parked crookedly and might hit me when opening its door, so I should choose another lower-risk option. This ability to think a few steps ahead is the essence of a reasoning chain. It marks FSD's evolution from a visual recognition tool into a true driving logic expert. When you see a vehicle recognize a hand gesture from an opposing driver at an intersection, or proactively reverse when sensing an approaching train in the distance, you truly feel that it is no longer cold code, but an entity with an IQ. However, to achieve full autonomy, the famous long-tail problem must still be conquered. I found that teaching a car 99% of daily driving is relatively easy, but the remaining 1%, like debris falling off a truck or a flock of ducks crossing the road, is often fatal. Tesla's solution is reinforcement learning. They extract moments that confuse the model from millions of vehicles worldwide and move them into a virtual world simulator, cloning thousands of variant scenarios for trial and error. The system gets a reward signal when it's right and is punished even for just touching the grass when it's wrong. This machine training machine model no longer relies on humans writing dead code. Instead, it allows the model to independently summarize the perfect strategy through countless failures. This speed of evolution is beyond human reach, because its training set comes from extreme real-world cases globally. Speaking of this, we must discuss the business logic of safety. I've always believed that in the field of autonomous driving, safety is not just an ethical issue, but a precise financial metric. While current FSD might be 1 to 2 times safer than human driving, this is far from enough for large-scale commercial operations. Interestingly, the industry consensus is that to achieve large-scale robotaxi operations without safety drivers, safety must be 5 to 10 times that of a human driver. It's like the aviation industry. We trust planes because their accident rate is several orders of magnitude lower than driving. Based on current data predictions, FSD is expected to break through this 10x safety threshold by the end of 2026. Musk's cautious testing in Austin confirms this. Current limitations aren't from hardware production capacity, but because the software's safety threshold hasn't been fully met. Once the software obtains this 10x safety certificate, the release of hardware capacity will restructure the market in an instant. When we look at the competitor Waymo, we see 2 completely different strategic logics. Waymo follows the laboratory bonsai route, relying on expensive LiDAR and high-precision maps. While it performs beautifully in specific areas, it is extremely costly and difficult to scale quickly. Tesla, on the other hand, is like a wild wolf, insisting on pure vision technology without relying on preset maps. As long as you give it eyes and a brain, it can survive in any environment. I've found that Tesla possesses 2 overwhelming competitive advantages: extremely low hardware costs and powerful vertical integration. Low costs allow it to collect a massive feedback loop through millions of owners worldwide. Vertical integration means that once the software matures, it can use OTA updates to allow existing inventory cars to join the autonomous driving network overnight. This internet-style zero marginal cost feature is likely to allow Tesla to overtake its competitors in a short time by 2026. Of course, to achieve true unsupervised driving, Tesla still needs to complete the last few pieces of the puzzle. First is the consistency problem. FSD cannot act like a veteran 99% of the time, only to make a rookie mistake like misidentifying a crosswalk in that 1% of the time. Second is the refinement of the end-to-end experience, such as how to elegantly drop off passengers at complex intersections, which directly determines a user's willingness to pay. Interestingly, to avoid relying on third-party maps, Tesla is building its own wing maps. Although they used low-resolution LiDAR for testing in Austin, this doesn't represent a return to the LiDAR route, but serves to provide a higher precision reference book for the visual brain. Furthermore, the integration of the Grok AI assistant will turn the vehicle from a tool into a private mobile assistant, allowing you to command the vehicle to handle complex itinerary tasks through natural language. Finally, let's step away from the car itself and look at how this revolution reshapes the fundamental architecture of civilization. I've found that throughout human history, cars, those expensive assets, have been idle 90% of the time. If autonomous driving can achieve extremely low costs and be 10 times safer than humans, then private car ownership will turn from a necessity into an expensive hobby. This will trigger a series of chain reactions. Real estate will no longer need as many parking lots, urban planning will be completely reconstructed, and insurance, maintenance, and even emergency medical systems will face disruption. According to my observations, we are standing on the edge of a massive technological chasm. On one side is the old era where cars are seen as auxiliary tools. On the other is a new era of cars as self-evolving intelligent agents. 2025 is very likely to be marked by history books as the true starting point of autonomous driving. When that string of cold code begins to take over the most common human skills in the physical world at scale, we truly realize that the logic of civilization's resource allocation is being completely rewritten. Although the process may bring growing pains and challenges, the torrent of technological evolution never stops. To summarize with a metaphor, current FSD is like a genius teenager going through a puberty growth spurt. It has mastered basic survival skills and is using this 10x parameter expansion to try and understand the world's complex logic and social unspoken rules. We are not just witnessing a software upgrade, we are witnessing the budding of a brand new life form in the physical world. When this teenager finally receives that 10x safety, coming of age certificate, the relationship between humanity and travel will change forever.